In Germany, anyone aiming to work independently as a carpenter must earn the title of Master. As part of the Master's Exam, each candidate builds a single piece of furniture. A piece that reflects their craftsmanship and understanding of the trade. For me, this is that piece. Hi there and welcome to this channel. My name is Maxim Leonard and I'm a practicing carpenter here in Germany. In this video, I'll take you through what it takes to become a master carpenter, sharing the process behind my final Master's Exam project. For this piece, I chose the classic wood combination of walnut and maple. Unlike maple wood, walnut is a challenging material with plenty of sapwood and cracks, requiring careful planning to manage the waste. I made sure all the main parts of the cabinet came from the same tree to avoid any noticeable color variations. Key considerations included standing growth rings from the middle board of the tree, ensuring broad surfaces from hardwood to sapwood, and selecting material that's not too thick or too thin, allowing adjustments to counter any potential cracks or uneven coloring. Using a hand plane, I removed the first layer of wood to see what lies beneath and to determine how far the sapwood has grown into the tree and where the hardwood begins. This is where I begin the process of breaking down large pieces of wood into smaller, manageable parts. I use a length-cutting, flat-toothed saw blade to rip through the slabs. By renting space at the Master School workshop here in Berlin, I had access to some remarkable machines which I might not see again for quite some time. Take this panel saw for instance. It's the first saw to use camera technology to automatically lower the blade in case it detects your hands too close to danger. A great technology which finds a useful application in tasks like this, as the use of templates and the initially rough accuracy requirements position the hands at a safe distance anyway, making it an effective safety net. However, for more precise work, it can be a real pain because it essentially prevents you from placing your hands anywhere near the saw blade, especially within about 120 millimeters of it. I found this to become nearly impossible, particularly when working with small parts. Once I've cut everything to rough dimensions, I move on to preparing the smaller pieces by creating a 90-degree edge on each board, setting the foundation for precision in the later stages. Then I transfer the 90-degree edges to the other two edges of the board using the planer, adjusting mostly the width and less the material thickness, since I still need to thickness after gluing up. Working with these machines, the piece almost seems to build itself. It's like taking a driver's test in a Porsche, only to go back to riding a bike once you've passed. For gluing these boards, I follow the principles of matching hardwood to hardwood and sapwood to sapwood, aiming for a symmetrical growth ring pattern. This ensures that any expansion and contraction will be counterbalanced rather than all shifting in one direction. Another gluing rule I considered during the cutting process was ensuring that the individual strips, which are glued together to form the board, are no wider than 80 millimeters. This ensures that the strips don't build up too much tension, which could cause the board to warp or bend in the future. I used the carpenter's triangle as a simple yet effective way to mark the sequence and position of the individual strips. This allows me to push them together during the gluing process until the triangle aligns perfectly at all joints. For good reason, this is one of the first things taught in apprenticeship training. After declamping the finished surface, I planed one side again to ensure that any waves or dents that may have built during the gluing process were eliminated. Then I used the thickness planer to bring the boards to their final thickness. The modern planers from Martin use a terza cutting shaft with razor-sharp reversible blades, which often produce a finish comparable to the quality of high-end furniture, theoretically eliminating the need for any further sanding in most cases. Once the boards have reached their final thickness, I cut them to their exact dimensions. This is a typical task where the saw blade would have abruptly dropped down into the saw's housing had I not covered the cameras with painter's tape beforehand.
Wow.
After the cabinet parts were glued and trimmed to their final dimensions, it was time to focus on the drawer slides. A seemingly abrupt jump, especially since the drawers didn't even exist yet. However, this sequence was necessary to route the grooves into the cabinet walls and glue the cabinet together as early as possible. For the drawers, I opted for traditional Kulissenführung, translating to grooved sliding track, made from maple. Maple is a hardwood with a close grain, well suited for friction, making it ideal for this type of application. When constructing a sliding track, it's important to create a form-fitting guide with a limited contact surface to allow smooth drawer movement. I chose a star-shaped profile, simply for its aesthetic appeal. Building these types of drawer runners is a complex task, and for me, it's something I do for an exam piece like this, surely not for everyday work. They're visually interesting but lack precision, adjustability, and the smoothness of more modern options.
perfekt. Genau, was ich brauche.
In order for the sliding track to function properly, it's important to set stop points to prevent the runner from sliding completely out of the cabinet. I achieved this by using shaft screws, which I threaded into the center runner using a tap. The shaft of the screw runs in a groove that I routed into the side section of the sliding track. This setup precisely defines the movement path of the runner and prevents the drawers from exiting the cabinet. It was time to mill the grooves into the cabinet sides. This was a somewhat risky operation as I routed each groove once in the same direction as the cutter's rotation to avoid tear out. This is generally not recommended as it causes the workpiece to accelerate to significant speeds. However, it results in a very clean cut and neatly severs the top fiber layer. For the drawers, I chose an English style design. The recessed front of the drawer is attached to the drawer sides with a single hidden dovetail joint, while the back is connected using 3 dovetails on each side for added strength. When selecting the wood for the drawers, I made sure the hardwood was facing outward so that any natural warping over time would pull against itself, keeping the drawers aligned rather than causing a bulge that would force the joints apart. The bottom is made from a self-made 3-layer plywood from Walnut, which is slotted into the sides and fronts and then screwed to the back. In addition, I included a pull-out serving tray in the center section of the furniture. This serves to protect the main surface of the piece, providing a designated area for preparing and serving drinks. Walnut is a very fibrous wood and tends to split easily under high pressure. Precision was especially important here. At the same time, I had to keep an eye on the clock, as I'd allocated only 1.5 days for all 3 drawers and the serving tray. One of the exam requirements was to incorporate a swivel or flap element into the furniture. I saw this idea in one of the pieces from previous year's master students and I thought it looked quite stylish, so I decided on swivel trays for holding champagne and wine glasses. If it hadn't been a requirement, I probably wouldn't have chosen these elements, as the swiveling action takes up more space than simply placing the glasses linear in the furniture. Still, it's a nice little feature. The keen-eyed among you may notice pencil marks on this board, indicating spots where I initially planned to drill 6 holes but ended up with only 4. This was an original mistake that turned out to be a blessing in disguise. The examiners pointed out that the rear hole was positioned too close to the edge of the swivel tray, which they saw as a potential weakness. If I had drilled all 6 holes, it could have led to risky business during the evaluation. For rounding the edges, I chose a radius of 80 mm. This seemed tight enough to create a defined look, while still rounded enough to allow the tambour slats to run smoothly along the curve. I used a laser to cut a 9mm plywood template, which I then followed with a flush trim router bit to cut the timber groove as cleanly as possible into the top and bottom panels. I did this in 2 passes to avoid putting unnecessary strain on the router bit and to have better control over the router, reducing the risk of mistakes. Before gluing up the cabinet, sanding and oiling were necessary. I sanded all interior surfaces with 120 grit and then moving on to 180 grit to achieve a soft, smooth finish on areas that would later be hard to reach. I then applied 2 coats of Osmo matte hard wax oil to all parts. I'm familiar with applying oil primarily by using a cloth or piece of fabric to spread it, letting it soak in, and after about 15 minutes wiping off the excess with a cloth or paper towel to polish it in. During this project I learned that the manufacturer recommends applying the oil with a textured roller and simply letting it absorb. Now, I'm uncertain which method is better. Personally, I feel the method I've always used creates a more beautiful surface, although it does require significantly more work. At this point it was time to glue up the main cabinet. There's not much to say about it other than that it was very stressful and didn't go particularly smoothly. In the end though, the piece came together and I had time to install the mirrored back panels. These are 5mm thick mirror glass with a 30mm bevel. It was important to me to cover the entire back wall with the mirror glass, as it aligns with the look of a bar and beautifully reflects the bottles and glasses that will be displayed later. Once the cabinet was glued up, I moved on to the exterior. This again involved the same old sanding and oiling. I lightly dampened the surface beforehand to raise the wood fibers, allowing me to achieve a smoother finish more quickly. This time I tried the roller method and was pleasantly surprised by how efficiently and quickly the oil could be applied. However, I later noticed that this method left a slightly uneven texture on the surface, which isn't necessarily an advantage.
Ja, aber für mich ist es ein Trick, weil ich es nicht kenne. Alter, das ist ja viel, viel geiler.
Between oiling sessions, it was time to focus on the Tambour Door. This consists of 126 walnut slats, each 20 by 20 mm, designed to keep the cabinet closed. Sorting and arranging the slats took quite a bit of time, as I wanted to achieve a specific look. Each slat has 2 striped sides and 2 with more dramatic wavy grain, often displaying a wild and beautiful pattern. I placed the most vibrant striking side facing up and arranged the slats so the grain pattern on each side flowed upward to the right or left, giving it a fiery character. I then routed 2 handle grooves with a 60mm half round bit for a minimalistic design. Sanding, breaking edges and more sanding. After that, I built a simple jig to hold the slats in place for each side of the tambour door. By driving in 2 wedges, I could fix and compress the slats, preventing glue from seeping between them. This also kept the slats tightly pressed together, creating a basic tension and better cohesion once the canvas backing was glued. Before gluing, I dampened the front of each slat to match the moisture they'd later absorb from the glue on the back, allowing them to dry evenly. To manage the already mounting time pressure, I opted for a heat-assisted glue up. I preheated the glue press to 60 degrees Celsius, which shortened the glue setting time to about 30 minutes. For applying glue, I used one of these glue rollers, which are truly worth their weight in gold. After gluing, when I lifted the shutter for the first time, I realized just how heavy it had become. On the plus side, this weight gives it some momentum once it starts rolling, but it also means that a certain amount of effort is needed to get it moving in the first place. I proceeded with rabbiting the slats, then sanding and oiling them as usual, 120, 180, and 2 coats of oil. Finally, I applied a layer of beeswax to both the slats and the track for smoother movement, mounted the stop points and closed off the entry points with screws. The main parts of the cabinet were completed, and it was time to focus on the base. For this, I used structural pine lumber to build the substructure. In this video, it looks quick and easy, but I must admit that I struggled with the double-angled slope of the upright beams and had to do a lot of trial and error to get the correct settings. The beams are reused from my old workshop setup, hence the numerous drill holes. After gluing, I moved on to sanding the curves, which I had roughly cut on the saw. I then fitted the crossbeam and the base was ready. Finally, it was time to attach the brass. Finding a company to laser cut and bend the brass parts as I needed was quite a challenge. Simple shapes aren't an issue for most, but when it comes to double angled surfaces and brass, I managed to find only one company in all of Berlin willing to take on the job. Initially, I wanted to create the base from a continuous brass sheet with just one seam at the back of the cabinet. However, I was told this wasn't feasible and the base would have to be made from 4 separate pieces. Soldering brass is apparently very challenging, so I decided to use a strong 2-component epoxy adhesive and simple aluminum brackets to bond the parts. This worked flawlessly and was a stronger joint than I had anticipated. All that was left was sanding and polishing the brass surface, which looks about 1,000 times easier in this video than it actually was. So after around 10 hours of sanding and polishing, I was finally ready to assemble the piece for the first time. Not because I was finished, but because I had run out of time and the examiner was scheduled to inspect the piece at 5 p.m. that day. After the initial inspection, one has to wait for about 2 months for the final critique, where 2 to 3 examiners would evaluate the piece and determine if I was worthy of the master title. My defense interview, to be honest, was quite intense and I was really put through the ringer. One major criticism from the examiners, for example, was that I should have joined the sides of the cabinet to the top and bottom using dovetail joints instead of using domino connectors. There were also some additional minor points regarding my drawings and other details. Stressful times, but in the end it was enough and I was awarded the master title in a formal ceremony a week later. Now the piece stands in our living room where it will live out its days as a home bar, hopefully for many years to come. Thanks a lot for watching my first ever YouTube video, and I'll see you in the next one.